Okay, here's some hashing examples. Hashing. So let's say we had some keys that showed up, and let's say we had just some arbitrary keys: a 12, a 21, 11, a 15, and a 27. So we could generate a hash algorithm. We could say h of key is, let's just say this depends on the data store. So let's say we wanted to store this into a 6-element array. So 1, 2, 3, 4, 5. The index would be 0 through 5 in a 6-element array. So this is our data store that we want to do. And the key h of the key, the hash algorithm has to mod by 6 because we want to generate indexes between 0 and 5. We could do anything we want to the key. We could just take the key itself and mod by 6, or we could take, you can do different things. So you could add the numbers together. Here we're just going to take the key itself and mod by 6. So making a little table here, h of the key. So 1 plus 2 is 3, mod 6 is, let's see, 1 plus, oh wait, sorry, we're not adding, we're just taking the key itself. So 12 mod 6, 6 goes in twice with a remainder of 0. Okay, 21, 6 goes in, 6 times 3 is 18, 19, 20, 21. So 6 goes in 3 times with a remainder of 3. 6 goes in once with a remainder of 5. 6 goes into this twice with a remainder of 3. 6 goes into this. 6 times 4 is 24, plus 3 would give you 7. All right, so those are the initial hashes, which are just the indexes. So now let's say the data shows up in this order, right? So 12 shows up. First thing you do is hash this 0. And so you go to location 0, you look, see that nobody's there. So nobody's there, so you take that spot. All right, so 12 comes in here and just sits down. And 21 comes along. And this is the order of arrival, right? The order the data shows up in. So 21 shows up, you hash a 3, you go to location 3, and nobody's there, so you put the 21 there. Okay, 11 shows up, you hash the 5, you go to location 5, there's nobody there, so you put the 11 there. Then what do we just do? 11? Yeah, 15 shows up, you hash the 3, you go to location 3, but somebody's there, so you have to resolve this collision. So the first thing we can do is just step by 1. So we'll just step over here and and we find a blank spot after we step, so we put the 15 in that location. Okay, 27 shows up, we go to location 3. We try to put it in 3, but there's somebody there, so we just start stepping. We step to the next spot, the next spot, the next spot, the next spot. Finally, we find a spot, so we sit down there, and that's the data. You need to leave this empty spot here. You can't put any more data in here because that would take this last spot, and you need to have an empty spot for when you look things up, because the way you look things up is like if we were gonna, so these were inserts. Now, if we wanted to do, a find, right? Like say we wanted to find 15. You'd start at 50. You'd hash this 3. So you'd go to location 3, and that's 3's not. You'd go to location 3, and 21 is there, but we're looking for 15. So you start stepping, and you find 15. But if you were going to find, say, somebody who's not here, like if you were going to find a 9, so 9 mod 6 is 3. So you'd go to location 3 looking for 9. It's not there, so you start stepping. Is this 9? No. Step again. Is that 9? No. Step again. That's not 9. Step again. That's not 9. Step one more spot. Empty spot. So 9's not there because he would have, if 9 were there, he would have taken this spot. Okay, so you need to maintain at least one empty spot. All right, that's this is basically linear or step by one. Okay, you could step by some other size, like say 2. This is sometimes called generalized linear rehashing, or step by some constant size, and some constant C. In this case, C is 2. So here's our data store. 0, 1, 2, 3, 4, 5. Same keys, but now we're going to step by 2. So 12 shows up, hashes to 0. There's nobody there. You stick him here. That was 12. 21 shows up, hashes to 3. You go to location 3. There's nobody there. You stick him there. 11 shows up, hashes to 5. You go to location 5. Nobody there. You stick him there. 3 shows up, hashes to 3. 21 is already there. So now you step by 2. That spot's also taken. So you step by 2 again, which will give you this blank spot. So that's where he goes, in this blank spot. 27 shows up. You start at 3. Kind of getting messy here. Go on this side. 27, there's somebody there. So now you step by 2 again. We're stepping by 2 here. So you try that, it's full. Try that, it's full. Try that. You're back to where you started from. Then let's see, 27. Yeah, it's going to roll around. It's going to roll around forever, and you're never going to get there. So that's basically, this is a bad step size, because this is a even number of data, and so you want an odd number of step size. Otherwise, you're going to keep rolling around. You're never going to find that blank spot. So step should not be what do you call it when it's even or odd, like the evenness? But step should not be even if data is even. If data size is even, or data should not be odd if data size is odd. Okay, so that's step by 2, or generalized linear rehashing. Okay, you could also chain, right? So the idea with chaining is you build a linked list off of every element. So 12 shows up, you put him, hashes to 0, you put him here. 13 shows up, hashes to 3. I'm sorry, 21 he shows up, it hashes to 3, you put him here. 11 shows up, hashes to 5, you put him here. 15 shows up, hashes to 3, you chain him off the side here. You build a linked list off the side. And then 27 shows up, hashes to 3. 21's there, so you follow the link. 15's there. That's the end of the chain, and so you just add another link. So if you were going to do a find 15, you'd hash to 3, you'd go here, and that's not 15, so you follow the link and you found it. Or if you were going to do find that same guy that hashes to 3, like if you were going to find 9, you'd start at 3, because 9 hashes to an index of 3. You would start at 3. 6 or 9, you're looking for 9. 9 is not 21, it's not 15, it's not 27, and you've reached the end of the list, so 9's not there. Okay, that's chaining. The other thing you could do is you could double hash. So here's your data store. Right? So 12 shows up, hashes to 0, you put him here. 21 shows up, hashes to 3, you put him here. 11 shows up, hashes to 5, you put him here. Okay, 15 shows up, hashes to 3. You go here, but there's somebody there. So now you step, but you generate a step size. Step size is H2 of key, where H2 of key is, and it's kind of arbitrary. We can just, let's say, mod by 3, and then we need to add 1 to make sure that we don't have a 0 step size. So then we generate, we're trying to resolve 15. So for 15 we need to do this. So H2 of 15 is going to be 15 modulo 3 plus 1. It's going to be, so 3 goes into 15. It goes in 5 times with the remainder of 0, plus 1 is 1. So the step size for 15 is 1. So we step by 1, and we find a location to put 15. And then 27 comes along. It wants to go in location 3. I'll put it over here because it's messy. I'll draw it over here. 27 shows up. There's a collision, so we need to generate a step size. So H2 of 27 is going to be 27 modulo 3 plus 1. So what is that? It's going to be 1, because 3 times 9 is 27. So 3 goes in 9 times with a remainder of 0 plus 1. So we step by 1, step by 1, step by 1, step by 1. We finally find a location to put 27. All right, so that's double hashing. So that's hashing with collision resolution. So the idea is you're going to get collisions because you don't know what data is going to show up. So you're going to get collisions. You can't predict what these keys are going to be. So you just resolve the collision by stepping in different ways. Here we're stepping by 1. Here we're stepping by some constant size 2. Here we're stepping by where each key has a unique step size. And the idea with these different stepping is just to kind of spread the data out in the array, right? Because you want to, spreading the data out sort of just reduces the probability of collisions. Okay. There's other pros and cons to these here, which have to do with more details of the memory system. Like, if you're stepping by a big step size, it might actually be worse, because you might have to load a new page of memory, right? Because the virtual memory system, not all the pages of memory are actually in RAM. So it could be worse. It just depends. There's details that might matter on these things. And then this chaining thing is just another way to do it. And once again, it kind of comes down to the details of the system that you're on. Okay, that's hashing. In case you didn't notice, this example I did is just the same example that I have posted. And there's also an additional example with some bigger numbers. All right? Thank you.